Bismillahirrahmanirrahim. Welcome to International Research Class. For this time, we will discuss about the one theory such as functional data analysis that arise in the one's research article that published in the international journal, namely Canadian Psychology, with the title Introduction to Functional Data Analysis. Okay, in the functional data analysis, we have the sum variable. For each variable, we have the sum data. And then for the all variable, will representative with the graph. And then, of course, we have the several overlapping graphs. So in the functional data analysis, we try make the smooth graph. Okay, you can imagine that from the several overlapping graphs, you try to produce the several smooth graphs. There is one theory that we can use to make the smooth graphs. We call that Fourier series. The Fourier series have the formula yt equal to d0 plus d1 sinus omega t plus d2 cosinus omega t plus d3 sin 2 omega t plus d4 cos 2 omega t, where omega equal to 2 power pi divide the t. So you can imagine that if we have this formula, we call that Fourier series with the basis 4, basis 5. Basis 5, it means we have the one's constant d0 and the 4 coefficient. And if we change by the basis 7, so it means we have the 1 constant and 6 coefficient. And then you can imagine that if we use the basis 65, we will have the 1 constant and we will have the 64D. Okay. Like the regression linear, the main issue in this Fourier series, we will find or produce the value for the constant and then the coefficient. We are using the matrix pi. The matrix pi is equal to, okay, you can see in this picture, in this slide, and then you will find the constant and coefficient by the formula pi transpose multiple pi, and then we take the inverse multiple by pi transpose and the multiple y. Y is mean the data. Okay. You can imagine that this is very simple techniques, but if we are imagine that we have the sums variable and the sum data, of course we are need the software like the R software. Okay, the all information about the functional data analysis you can find in the 2 sources. The first source is the books with the title Functional Data Analysis with R and MATLAB. In these books, you can understand with the very clearly how to the R software solve the problem about the functional data analysis. And then the second books, Functional Data Analysis, this is the theoretical for the functional data analysis. If you combine these 2 books, you can very easy to understand about that. What is the functional data analysis? Okay, now we can try to open our R programming to the supports our discussion today. Okay, we try to open our R programming. Okay, this is our R programming. Okay, for the first time, don't forget to download the package. We call that FDA. FDA is mean the functional data analysis. Okay, you can try download from this tool package. You can find the FDA. Okay, after you are download success download the FDA, you can use the library FDA. Okay, for the first time, we open our program about the FDA. We call that FDA explanation by R. Okay, this one. We open our data. The first time open our data. Okay, our data about the basic commodity. Basics the commodity. Okay, basic the commodity. Okay, where is our data? Okay, this is our data. Okay. So we come to the console. Okay, we types our data. Okay, it's our data. There are the 20 basics commodity. This data about the daily average price. Okay, daily average price. The 20 basic commodity. We have the onions, we have the chili, we have the potato. And then we have the data, the daily average price. Okay, start from the first until the 366 for the each variable, because we know for the yearly we have the daily around the 366. Okay, to our discussion today, for our discussion today, we only use the 10, the basics commodity. Okay, we only use 10, the basic data. We only use the 10 variable. The variable are basics commodity. Okay. We use only the data in the column 1. Okay, and then data in the column 2 until the data in the column 10. Like I said before, we only use the 10 basics commodity. Okay, we run our data. Okay. Okay, you can check here. If I try to take the FDAB Fox copy and then you paste here, you can see we only use the 10 basics commodity only. Okay. So the first time, like I said before, these 10 variable will representative by the several overlapping graphs. So because we only have the 10 variable, it means we have the 10 overlapping graphs. Okay. In this program, we try to make the plots. Okay, we try to make the plots for the 10 variables. Okay, you can see here. There is 10 graphs with the 10 line. So you can check here. So very, very complicated graphs. The several overlapping graphs or the 10 overlapping graphs. This is about the beginning and in the functional data analysis. So from 10 overlapping graphs, we will produce the smooth graph. Okay, using the Fourier series function. Okay, so in our programming, we use the 65 basis. 65 basis, it means we have the one constant and we have the 64 coefficient. So we give name day basis 65. In the R programming, there is the ones program called that create.Fourier.basis. This is for the basis, number of basis, and then this is the number of our data. Okay, so we can run our programming in R. Okay, functional data analysis. Okay, we run our programming. Okay, we can come to the console. Okay, oh, data FDA. Okay, forget. We try to give name the data, become data. Okay, data. Forget to give the name DTA FDA for our data. So we run again. We run again our program. Okay, we run. Okay, we check in the console. Okay, the all programs can run well. So we can check day basis 66. Copy here, and then you paste here, you enter. You can check here. There is the one constant, and then there is the 64 coefficient. Okay, sin 1, cos 1, okay, sin 2, cos 2, okay, until the sin 32 and the sin and the cosinus 32. So it means we have the one constant and the 64 for the coefficient. Okay. So after we run the day basis 65, we can check the 10 smooth graph using our programming plot. Okay. Windows graphic. Windows console. Okay. 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 We have the problem. Okay, this one. Plot. Okay, we plot. Okay, you can check here. This is one. Nah. You can make the comparison. This is the 10 smooth graphs by using the Fourier series with the basis 65. So very different with the 10 overlapping graphs. This is the this is smooth graphs by using Fourier series with the 65 basis. And then after we have the smooth graph by the basis 65, we try to make the new smooth graph with the basis 7. Basis 7, it means we have the one constant denol and we have the 6 coefficient. Okay, we run our program again and we try to check the smooth graph. Okay, we check the smooth graph. So very different smooth graph when we make the comparison with the smooth graph with the 65 basis. In this one, in this graphic, this is the smooth graph by using the 7 basis. Okay, after that, we are trying to change with the basis 5. Basis 5 is mean we have the one constant and the 4 coefficient. Okay, our program and we check the graph. We check the smooth graph. Okay, this is very smooth. Okay, so it's our discussion today. We have the 3 kind of the smooth graphs for the each smooth graph produced by the Fourier series function with the 65 bases, 7 bases, and the 5 bases. So the problem is which one is the best? Which one is the best? So to check the best one, we will try to use the one variable only, like in our data, we use the column 3. Column 3 may be for the potatoes. We just do the potatoes. So ZZ is mean the real value of the daily average price for the potato. ZZ1, it mean is the daily price, daily average price for the potato that produced by the Fourier series with the 65 bases. And ZZ2, it mean is the daily average price of the potato produced by the Fourier series function with the 7 bases. And ZZ3, it means the daily average price for the potato that produced by the Fourier series function with the 5 bases. So we can make comparison. Which one is the best? Of course, so very close with the real data. Real data, it means the real daily average price for the potato. Okay, so we run our program. Okay, we can check here. So you can check here. There is the black one, the dot black is this the real daily average price for the potato, and the blue one is this daily price, daily average price potato from the Fourier series function with the 65 bases, and the red one is the daily average price of the potato produced from the Fourier series function with the 7 bases. And the green one is this daily average price, the potato that produced from the Fourier series function with the 5 bases. You can check and you can see the blue one is the best one. The blue one is the best one. So we can imagine that we can produce the new data for the daily average price of the 10 commodity. So in the R programming, if you want to check the data, the potatoes, you can type eval.fd. Okay, like this one. We copy here and we paste, we try to enter. You can check here. This is the daily average price potato that produced by the Fourier series function with the 65 bases. You can check here, the all data is the full. Start in the first until the start in the 1 day until the 360 day. And if you are comparison with the real data ZZ, you can check here. There is the zero data for the 360 and the 361. It means there are the missing data in the real data for the 360 days and the 361 days. So it means by using the smoothing graph that produced by the Fourier series, the all data is full, complete data. Okay, like this one. This is the data for the 360 days, and then this one for the data in the 361 days. So it's mean if you have the problem in the missing value in the real data, you can make the estimation the data by using functional data analysis. We have proved this theory like this one. The real data is 0. So by using this functional data analysis, we can estimate the data. So it means the problem in missing value we can solve by the functional data analysis. So the functional data analysis not only make the smooth graph, but the functional analysis we can handle for the find the missing value. Okay, and then the functional analysis can give the estimates value or can give the new data with the same characteristic with the real data. Okay. This is the theoretical about the functional data analysis. Okay. So, from our discussion today, we have the conclusion. We have the some conclusion. If we have the several variable, for each several variable, we have the some data. So, of course, we will have the overlapping graphs. It is difficult to make analysis when we have the several overlapping graphs. And then by the functional data analysis, we try to make the smooth graph. The one theory to make the smooth graphs, we call that the series. Okay, this is the series function, Fourier series function, or we call that sinus and cosinus function. It depends on the number of the basis that you use. If you use this 65 basis, it means we have the one constant and the 64 coefficient. And we have the 7 basis, it means we have the one constant and the 6 coefficient. And using R programming, we can make the easy to solve this problem. We have tried for this discussion. Okay, for our student or the researchers who needs the R programming, we can try to open by slowly, and then you can use this programming at your home to support your research, of course. Okay, for the first time, of course, we have to call our data and make your data, management your data, give the goods name like this like this discussion. I give the FDA BEPOK. In Indonesian language, BEPOK is this bahan pokok. In the English language, we call that basic commodity. Okay, and then try to make the graph. Okay, this is to make the graph. You will find the sum overlapping graphs. After you have this graph, you try to make the smooth graphs with give the number of bases. Don't forget, give the name our data now DTA FDA list FDA box, and then you can run here. You can use this program. You can check here. I think it's very easy program. That after the program run, you try to make the plots. Okay, the plots, the smooth plots, the smooth graphs. Okay, the smooth graphs, and then try change the basis by the 7 basis, and then we make the same program. I think the same program. We only change the 65 become the 7. Okay, you run your program and then you try to make plot again. And then you try to change with the basis 5. Okay, the same program, you can run here and then you try make the plots again. Then after that, we try to make the comparison ZZ for the specific variable. For this, our discussion today, we use the column 3 for the potato and ZZ1 for the basis 65, ZZ2 for the 7, and 6, and ZZ3 for the 5, and then they'll make the comparison. Okay. After we are mixed comparison, you can use the maximum absolute error. Okay, not maximum, mean absolute error. Mean absolute error, it means the real data minus the data from the Fourier series that we know ZZ1 from the Fourier series with the 65 basis. We call that MAE1. MAE1 is mean the mean absolute error, and then MAE2 mean absolute error for the real data minus the data from the data that we produce by the Fourier series with the basis 7, and then MA3 for the Fourier series basis 5. The smallest one we say is the best smooth, the best basis for the smooth graph. Okay, we run MAE. Okay, we run here, and then we come to the console. We check one by one. MAE1, so 501. MAE2, okay, 600, and MAE3. Okay, you can check here. MAE1 is the best basis that we use in this theory. Okay, I think our discussion today is enough. It's a very nice discussion. For the another discussion, we will try to produce smooth graph by Roughness penalty. Okay, by Roughness penalty methods. After we have the fixed basis, so from the 65 basis, we try to make the smooth graph again by the theory we call that Roughness penalty. Okay, Rado Yendra International Research Class. See you again.